Alright, part 2 of this lab doesn't require any scale. Previously you need to be very careful about what your scale was and how you measured things. But for this one, all you need to do is measure the angles. Since FT1 is 12 degrees above the x-axis, and FT2 is, find the hole in the center, line up your 0 scale with the x-axis, and FT2 is coming out at a 55 degree angle. This is a 55 degree angle. This one, F3, I'm going to take it, find the head center in the hole, there, and this is coming out at a 14 degree angle. 10, 15, 20. So this here is a 14 degree angle. So for each vector, at this point, these lines are more symbolic than anything. This FT3 is actually a y component, F3y, and an x component, F3x. Now I don't care if these lines are exactly perpendicular or perfect, but I'm just going to show them what they are. Just like this, FT2 is a y component and an x component. Call this F2x and F2y. Same thing over here, FT1, F1y and F1x. I'm just going to do one of these because I'm sure you can do the trig on your own. But to find F1x, since the adjacent to the 17 degree angle, SOHCAHTOA gives us that the cosine of 17 degrees is equal to F1x over F1, FT1. Since FT1 is 6.5 newtons, I can then do the math and say that 6.5 cosine of 17 is equal to 6.2 newtons. Round to the nearest tenth, that's fine. Okay, just to verify, F1y is going to be the sine, so 6.5 sine of 17 should be smaller than, the blue arrow should be smaller than the red arrow. So this ends up being 1.9 newtons. Okay, do the same thing for F2y and F3y, and then do the same thing for F2x and F3x. Now at the end of the day, what you should be able to find is that the sum of the forces in the x direction are equal to 0, because this was an equilibrium. So just for fun, I'm going to do the other x's and show what they are. F2x is equal to the adjacent to the 55, so it ends up being 7.2 adjacent cosine of 55, or 4.1 newtons, and F3x is the opposite to the 14 degree angle. So it ends up being 7.8 sine of 14 equals 1.9 newtons. Now this is in the positive direction, this is in the positive direction, this is in the negative direction, so I'm going to put a little negative sign there. So when I sum the forces in the x direction, equals F1x plus F2x plus F3x, this is going to equal negative 6.2 newtons plus 4.1 newtons plus 1.9 newtons, which equals 4.1 plus 1.9 equals negative 0.2. Close enough. You get anything under half newton and you're fine. Do the same thing in the y direction for F1y, F2y, and F3y, and it should also equal 0. This mathematical or trigonometric proof is the second part of this lab.